All right, so in this video, I'm just going to talk about why you might have a hole in a rational function, what that means, what it looks like, how we find it, and so forth. So in our rational functions packet, you were given this question number 9. And so I hope when you looked at it, you noticed that we have a quadratic here at the top, and we also have a quadratic here on the bottom. And so my first job is to take this and to factor. And so remember, when I am factoring, I am trying to multiply two terms that are going to give me the C value or the C term and add to give me the B value. So I'm looking to add to give me this one and multiply to give me this one. So since I start with an x squared term in the beginning, I know that I have an x and an x. And so now I'm thinking to myself, what is going to multiply to give me negative 20? And I need those two numbers to add to give me 8. So multiplies to negative 20 would be negative 10 and 2. And then if I were to do negative 10 plus 2, I get negative 8 instead of positive 8. So then I'm going to switch it to be a plus 10 and a minus 2. Because 10 minus 2 will make 8. And 10 times negative 2 is negative 20. I am then going to do the same thing for the denominator. So if you need to think about this as being x squared plus 0x, right, because I'm missing that b term, minus 4, you can do so. But basically, I need to multiply to get to negative 4 and add up to make 0. And the only way I can do that is if I have a plus 2 and a minus 2. And so at this point, you might be noticing, oh my goodness, there is an x minus 2 on the top and an x minus 2 on the bottom. So I'm going to cancel those two out. So the remaining function that I have is x plus 10 over x plus 2. So I'm going to use this function to get my VA, my vertical asymptote. And so the only thing that'll make that denominator 0 is if x is negative 2. So then I'm going to go ahead and draw that in with my highlighter, negative 2. Whoop, that's really pretty. Then I'm going to get my horizontal asymptote, so I can see that the exponent of the top is 1 and the degree of the bottom is 1, so 1, and then their coefficients are both 1. So 1 divided by 1 means that my horizontal asymptote is at 1. So I can go ahead and add that in. And now I have a pretty good start for my function. But there's this weird thing called a hole. So what's happening is with this function is that if I were to put in positive 2, I would get 0 in the denominator, right? Because 0 squared minus 4, 2 squared minus 4 is going to make 0. 2 times 2 is 4, minus 4 makes 0. So whatever over here gets canceled out, whatever makes this 0, what makes 0? Is going to be the x coordinate of the hole. And so I know that 2 minus 2 makes 0. So I know I'm going to have a hole when x is 2. But then I have to figure out what is y when x is 2. So in order to figure out the y coordinate, I'm going to plug 2 into my new function. So I'm going to do 2 plus 10, because my function was x plus 10, over 2 plus 2. And so then I would have 12 divided by 4, which is 3. And so what's happening with this graph is that it's going along swimmingly or nicely. And when it gets to the point 2, 3, it skips that point because it does not exist. So I'm going to physically draw an open circle at 2, 3. Then just as we did before, I'm going to make a little table of values. And I'm going to figure out what is happening in this graph. So I'm going to plug in 0. When I plug in 0, I get 10 over 2. So that's going to give me 5. So I'm going to come up and plot a point at 0, 5. I think I'll plug in 1. 1 plus 10 is 11 divided by 3. What's 11 divided by 3? 3 point something.